Test, test. Howdy, everybody. Good evening. My name is Ruben Ramirez, and I'm going to attempt to use the mic stand and the mic during the session. Uh, oh, cool. Ooh. Oh, man, I'm clicking buttons already. It's great. I was practicing, I promise. All right. Good evening, everybody. So my name is Ruben Ramirez. I typically try not to talk about myself, but I guess I should introduce myself. So I am a NASA Lucy ambassador. What that means is I am part of the NASA L-Space program. There are some slides, I think, at the very, 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 very end that kind of talk about that program, but ultimately we'll get into it more at the end. So cool. I'm here to talk about the NASA Lucy mission, an epic journey to the fossils of our solar system. So just out of curiosity, how many of you are familiar with the Lucy mission? You can be honest. Cool, cool, yeah. Well, if you have not heard of the Lucy mission, I'm actually really excited to talk about it with you. There's a couple missions in here that I'm not too familiar with, so if you have questions, forgive me later, but NASA Lucy mission is actually one of the first ones I've really dived into. If you're an ambassador, you should, right? So I'm going to do my best tonight. So in addition to the planets, typically, when we think of the solar system, we're thinking of the inner solar system, right? You see the Earth, Mercury, Mars, Venus, and then later Neptune, etc., all the other planets. So our solar system is filled with the ancient remnants of planet formations, also known as asteroids. When you think of solar systems and you think of the inner solar system, you think of rocky planets, of larger planets, but they're actually filled more with asteroids and a bunch of space debris with organic material that can teach us about our universe, right? So, awesome. Keep moving on. So NASA is sending a mission to a never-before-explored group of these planetary fossils. In honor of a human ancestor fossil found in Ethiopia, the mission is named Lucy. The Lucy fossils were discovered in Ethiopia about, I think, 1974, and they are about 3 million years old. So kind of a testament to just ancient knowledge, right? Learning about how we came to be in the universe. And up here is a diagram. Do I have a laser pointer? Yeah. So here we are, Earth, and this is our main asteroid belt. How many of you if you potentially even knew that we had a Trojan asteroid belt? Yeah, awesome. A few hands. Yes, yes. I'm going to bring up Lagrange points, I promise. That's actually a great segue into that. Thank you. So Lagrange points, they are, think of it as when you are like in a ring around the rosy with your friends, right? And everybody's going around the ring around the rosy. You're still in that same, what you would call position, right? So Lagrange points are held between the orbit of Jupiter, and there are 2 Lagrange points here. So they consistently follow Jupiter's orbit around the main asteroid belt. I don't think there's a slide that will show the Kuiper belt, if I pronounced that right, forgive me. The Kuiper belt contains a lot of those those outer organic material and debris and asteroids that we're really mostly interested in. But over time, when we were first starting, or when the solar system 4 billion years ago, when our solar system formed, we believe that many of the outer belt contains a lot of that old debris and organic material. So we're going to keep moving on. So what are the Trojan asteroids going to teach us? They're going to teach us how our planets formed. They're going to teach us how, especially the 4 giant planets formed. A lot of that atmosphere, when we look at our giant planets, we can't really get to that, right? Like there's millions of pressure that's million times the pressure that we have on Earth. So we really have a hard time studying those that inner rock in the planets. If we travel to the Trojan asteroid belt on the Lucy mission, we're really going to get a lot of those same remnants and a lot of those same materials, and it's going to continue to teach us a lot of the history of our universe. So what are the Trojan asteroids going to teach us? Lucy's data will help scientists to just questions like, what rocky and icy materials make up the giant planets? How and where did these planets form? Did they move around in the early solar system? How did the materials needed for life make it to Earth? So NASA is going on a road trip to a record-breaking number of asteroids. I could be wrong, but I think well, I shouldn't say. So yeah, we're visiting 11 asteroids, 8 in the Trojan Asteroid belt and 1 in the inner belt. And there's actually 2 that are what we would call satellites. So they orbit some other, you'll see later in the slides that they orbit some different asteroids that we weren't able to really see with some of the instruments on the Lucy spacecraft. We could see black and white images with, I think it's the Ralph instrument or the tests. I'm mixing them up, forgive me. But as I digress, yeah, we discovered some neat things, and we're going to continue to discover more things as we travel closer. So when we travel, or if you were to travel 65 miles per hour on the same Lucy mission, it would take 7,000 years to fully go around. But the Lucy spacecraft is going at an average of 15 kilometers a second, at its top speed 40 kilometers per second. So somewhere between 40,000 miles per hour and 90,000 miles per hour. So huge difference, right? That will take 12 years. So I believe the mission launched on October 16th in 2021. And we have already visited Donald Johanson. It's actually not mentioned in the slides, but as we found our orbital mechanics and understood the best ways to travel efficiently, we noticed very conveniently an asteroid by the name of Donald Johanson was named. If you're wondering what that connection is, the Lucy mission named by the ancient fossil Lucy, right? They went ahead and named that very first asteroid Donald Johanson after the gentleman who discovered Lucy. So really neat Easter eggs. Awesome. I'm gonna be honest, I did study some other material and the slides are kind of unfriendly. So if you notice I'm going back and forth, forgive me. I'll do my best to intertwine that information. Thank you. So here's the Lucy spacecraft. It is about 15 meters long. The bus is the central system there. You can see I think that's the El Ralph on top, and the 2 solar sails on the side. Yeah, some good stuff. So the main bus is actually about the size of a convertible car. I think on the... Yeah, probably. And that is Hal Levinson. If you're wondering who that is, he's the principal investigator of the mission. As part of the NASA space program, if there's any students here or potential early career engineers, we actually get a lecture from Hal Levinson. As a mentor, I've been able to see it twice already, but as you experience the Academy, you'll see it once. And he's such a great gentleman, and a lot of the information, and he's so knowledgeable. And one of my favorite parts about learning about the Lucy mission is they're like NASA is known for being very, very family oriented, very friendly, very just supportive, right? And a lot of what I heard from the principal investigator, Hal Levinson, and his deputy project manager, Miss Bradshaw, they really just talked a lot about how they supported each other. If you are familiar with the years of the Lucy mission, some of that happened during some of the, I guess I could say, COVID, right? So a lot of those things happening had to be virtual. And when you're working on a spacecraft, you need hands. you need technicians, you need people in the shop. So a lot of what Ms. Bradshaw and Hal Levinson had to do was go virtual and coordinate a lot of those things online and a lot of that planning. And the neat thing that I loved hearing about was that they hit every single key milestone without much issue, if at all. So if you're familiar with mission architecture, hitting those key milestones is pretty tough. There's a lot of you put margin in, and then you get more margin because it didn't work. So to hear from them themselves that they were very proud of their team for hitting all those key milestones relatively well, I just think it's awesome. It's a very successful mission. So we continue. Sorry for that rant. A little off script. Here is a picture of the Lucy spacecraft out at Lockheed Martin in Colorado. They're only able to pretty much deploy one solar sail at the time that they're working. So yeah, cool stuff. I'll leave it up there for a bit. So you'll see the bus right here. The memory is stored on here, so you can actually get information within hours. Though transmission can potentially take weeks or months, right? I know there might be some disconnect on there, but I was kind of studying. I was like, wait, this article tells me we get it in hours. This one says it takes weeks. So if you're familiar with that, I won't bore you with all that technical talk, but still pretty fast than most instruments than we can acquire information from, right? I don't think you could see. Yeah, I don't think there's thrusters in here, but the thrusters are from Aerojet Rocketdyne. They are MR103Js. I'm mostly familiar with like hobby rocketry motors, so like H motors, LM, all the things. So I kind of had to double check the force of those thrusters, and it's about 200 to 225 newtons of force, which is very low power because when you're in space, you actually don't need that much propulsion. Once you're there, you can just use as little as possible. When the vehicle, and you'll still get far, right? Especially if you're good with orbital mechanics. So. When it launched, the amount of fuel on the vehicle was actually equal to the fuel size. I think it was 800 kilograms was noted for dry mass, and then with the actual with the fuel, it was about 1.5 tons. So yeah. So yeah, Lucy launched from Cape Canaveral, Florida at 5:34 a.m. on October 16th, 2021. One of the mentors actually works at ULA, and he's on the test engineer team. Yeah, he was like, "Hey guys, I'm out this week. I'm gonna go test some cryogenic engines." I was like, "All right, Andrew, cool." So this is a ULA 5401. It is not a solid core rocket engine. So awesome. We're going to keep going. Lucy will start out flying by the Earth twice, using the Earth's gravity to speed up the spacecraft. So when I say orbital mechanics, I actually don't know a lot about it, but what I do understand is EGA, so Earth Gravity Assist. So this vehicle is actually launched on a minimum rocket power. So we just launched it enough to use the Earth Gravity Assist to go around once and then take its first, dress rehearsal. It followed Donald Johanson, I think, after the first gravity assist, and we used the tracking system from one of the instruments. I will remember the instrument soon, but that one we actually used the camera to help the tracking system follow those asteroids and understand where it's going. So really cool stuff, right? We're not just taking images up close to have detailed views and understand how they look and the geology of it, but also to help navigate, right? Really, really purposeful. So, fun fact, Lucy was the closest to Jupiter right before the first Earth flyby. Yeah, you would think even though it's going to be going around the Trojan Asteroid belt, it's close to Jupiter, but it was actually the closest on right before the first Earth flyby. Lucy captured images of the Earth and Moon as practice for the asteroid flybys. So, yes, the instrument was Elori Mosaic. I think that's the black and white one, and the T2 cam images as well. So the first asteroid encounter, a tiny main belt asteroid, Dinkinish. I'm trying to remember if it was Dinkinish or John L. Johansson, but slides say Dinkinish. So that was on November 1st, 2023, which was 2 years after we launched, right? Dinkinish had a surprise, a satellite named Salam. If you know some of those Easter eggs, right? Lucy mission, Donald Johanson, the satellite Salam is actually a testament to another fossil discovery, a 3-year-old fossil, a fossil of a 3-year-old girl, and it was named Salam by those who discovered it. So at NASA, they decided to also name the satellite Salam. Thought that was pretty neat. So here are some of those images. Awesome. We're going to keep going. So first contact binary satellite ever seen. Yeah. As far as I know, gravity is interesting, right? And when you, sorry, I'm obviously a little nervous. Forgive me. So that means they are still in contact and are orbiting, which the last two asteroids do this as well, but on a much larger scale, right? So these are smaller in size. I don't remember how small Dinkinish was, but it I think it was less than a kilometer long. So compared to the rest, who are like 21 kilometers long or 40 kilometers long, even pretty small, right? So here are the instruments: El Lori, the T2 cam, El Ralph, El Tess. There's the high gain antenna, solar sails. I believe later on it also mentions the solar sails. The left one was not fully deployed. It was like deployed 95% or 98%, but really low risk margin, right? Otherwise, everything ran so well and was very successful, which is hard. El Lori, the high resolution black and white camera, there it is, that's the black and white camera, will show us craters and other geological features of the Trojans. The El Ralph is a multi, I promise, multi-spectral visible imagery camera, the color camera, and this will help us understand what the Trojans are made of. So we'll get to see some of those chemical compositions, types of organic molecules that they have, things like that. The El Ralph has the instrument LISA, so it is an infrared spectrometer. It's actually, so when in NASA there's these instruments, and so many people will say like, oh, like NASA like is kind of slower than other other companies, right? But I think it's a testament to the safety. I've had opportunities to speak to several engineers, and some of the things that I learned right away were that they really love safety. Heritage instruments are important. So Ralph was actually on the New Horizon, and it actually was updated as El Ralph for the Lucy mission. So they take things that they've used, that they trust, and they try to make them better over time. And a little example of that. So this camera will help us understand what the Trojans are made of, especially what types of ice they have. So LTES is an infrared thermometer. So another heritage instrument from the OSIRIS-REx mission, just upgraded and renamed to LTES. This camera will take the temperature of the target, so it will measure how Trojan asteroids store the sun's heat, teaches us about the asteroid's surface. After the second Earth flyby, Lucy will head out to the Trojan asteroids. And that was on December 2024. I think the next one's in 2027, and we'll see that as well when we continue to go through the asteroids. So full dress rehearsal was done on Donald Johanson. Yeah, there it is. So another main belt asteroid. And that is a picture of Donald Johanson. On April 2025, so just last year, that was when we saw Donald Johanson. A complicated fragment of this recent collision. So I think Eubates is one of the, if not the only asteroid that was potentially a collision asteroid, and we think that was from the main collision. We think that was the main asteroid of the collision. This is just a fragment of that collision, or another collision. So lots of interesting features to study. If you're a geologist or studying all those astrophysics, biology, I'm sure you are really into that kind of stuff. Lots of interesting features to study, maybe ice cream cones. For the record, I did not develop or create these slides. They are given they are given to us as ambassadors. So that's where that comes from. Fun stuff, right? Yes. So first Trojan asteroid survivor of a massive collision. Eubates flyby on August 12th, 2027. So that's our next one. So that leaves what? 1, 2, 3. There are still 8. Can I math? Asteroids that we have to visit. So we've actually just begun this mission, right? In hindsight, or halfway through, some might consider, but yeah. I think we launched in 2021, ends in 2033. So we still have many, many years to go. So this is Eubates. Queta, if I'm pronouncing that right, is another satellite of that asteroid. The reason this image looks as bad as it is, or as less as little as it is because we can't really see that far yet. Once we have that flyby, we'll get better images. So it's mostly what we have from our own telescopes that have been redirected to go to study some of those with images, or artist renditions, right? So yeah, we actually don't know what they look like. That's why we want to go. Lucy's smallest Trojan target, Polymel, that will also be a month after Eurybates, September 15th, 2027. And these swirls, if you haven't caught on already, these are the Earth flybys. In blue is Earth, in red the flybys, and in gold those, or orange, if you would say, those asteroids. The asteroids are visiting. It also has a satellite, but I don't think I had much luck understanding if we named it or not. So it just says a satellite here, but yes. There is the third Trojan asteroid, Lucius. We have that for the following year, April 18th, 2028. Oh, sorry. Whoa, getting a little ahead of myself. There we go. We lost everything. Lucius, there we are. We're back to it. Cool. Awesome. Well, if I think of anything that I have more planted up here, I may riff with that, but we'll keep going through these. They're just asteroids, and yeah, cool stuff. I still think it's cool stuff. Fourth Trojan asteroid, Lucy's reddest Trojan target, Orus. I believe this is the one. Is it? Yeah, this might be the one where um, it rotates or no, orbits extremely slowly, or no, rotates. There's, yeah, some of these. So Lucius and Polymel and Eurybates, they'll rotate at like high speeds as they go through their own orbit in the Trojan asteroid belt, but Orus rotates extremely slowly. Um, that's just the universe. I couldn't tell you why. Apologies. Yeah, orbits. Yeah. So home for one last course. So after we visit all of these, that's when we'll do our third flyby. Yeah, third Earth flyby, Earth gravity assist. So there we go. And that will be in 2030. And I think you can also see these. You can also see the spacecraft if you. I I'm sure you need like high-level telescopes, right? But I am told and under the impression that when it's as close to Earth as it gets during the flybys and the Earth gravity assists, that we're able to see that. I'm also told we can see the ISS, but I've never attempted to look for it. So, yeah. Final targets, two for the price of one. Patroclus and Monoceus. So these two are, as I was mentioning earlier, how some satellites and those they will orbit an asteroid, right? These two are together, and they are, I guess you could say, in their own. Forgive me if the physics is wrong, but I think in their own like Lagrange gravity to each other, they're tied to each other, and they just are always rotating and orbiting. So they're together. They're a pair. You find one, the other one's right next to it. So pretty neat. We're really interested in that because you don't see that in the main asteroid belt. Some of those things you see more in the Kuiper belt or further out of our belts, but seeing the binary systems, are things that are very interesting to us, and we hope to learn more about. So. So these are all the amazing hardworking people, and there are definitely hundreds more behind them, not pictured here, that worked on this mission. So Hal Levinson, Mrs. Bradshaw, and yes, some of the interns as well, engineers. And the Lucy mission was in part with Southwest Research Institute, Lockheed Martin supplied the spacecraft, Goddard, Arizona State University, and these other amazing organizations. So NASA works together, right? As we've been hearing a lot of news, I think learning to collaborate more and continue relationships like this are very important. And we've been doing them since the start, right? With Boeing way back in the day, and now we see things going on with Blue Origin and Firefly. So I think it's an exciting time, right? Cool. Lucy is training the next generation of NASA scientists and engineers. So the NASA L-Space program is for college students. If you read the fine print, I swear it's also for early career professionals. So if you're just a year or potentially 2 years out of graduation, you still have the opportunity to participate in the Mission Concept Academy and the NPW, National NASA Proposal and Writing Evaluation. If you have questions for those, I'd love to hear them when we get there. But the last thing I'll say about the program is that it's really great. If I can lightly talk about myself a little bit more, I used to be a teacher. I taught for 5 years elementary/middle school mathematics. And when I decided to leave to pursue engineering, I taught STEM so much I decided to pursue it myself. I was kind of nervous because I didn't really know much about engineering. I found the rocketry team at Austin Community College, ACC SEDS rocketry, and I just immediately fell in love with aerospace. The L-Space program really prepared me for just what I understand about the industry, what I should learn about the industry, things that I need to know for engineering, real life things that go on in that work. And I just feel so much more confident trying to at least start anything related to space or the space workforce because of the things that I learned in here. The MCA is really mission oriented, so you work with Gantt charts, you do all these things with your team of engineers, you work on technical reports, preliminary design reviews, and for what it's worth, of course, it's done in a semester, but I think the process and the stunt growth, right? Like oh my gosh, like I have to do what, and I'm learning from who, and this is NASA, so it's a great program. I'll leave it with that. But cool. Lucy's journey will continue for thousands of years. The Lucy spacecraft can switch between these Lagrange points, or I shouldn't say switch, can orbit through these Lagrange points. There was so much fuel, I couldn't tell you how much would be left after 2033, but I'm going to assume we have a lot. And even then, as far as I understand, the orbit that it will be in can, as we see here, go between Earth's gravity and the Trojan Asteroid belts, the two Lagrange points here. So pretty cool stuff. I think that's awesome. These are kind of just backup slides, if you will, but they show a lot more stuff, so we might as well go through them, right? The Lucy plaque, a time capsule for our descendants. And that is Hal Levinson. So 12 years, 11 asteroids, 1 spacecraft, the Lucy mission. I hope you enjoyed all of those things. I would go to the slide. I'm more than happy to maneuver the slides if anyone has a question on an instrument or on the spacecraft, or if you want to see a picture again. But yeah. Oh, here's some more pictures. So solar sails, awesome stuff. That is an instrument. We'll leave it at that. I'll save myself. Lucy traveled to Florida and was encapsuled for a launch. So all the launches typically happen at Cape Canaveral, for those of you wondering, or I'm sure several of you knew that already. A successful test of the terminal tracking system. Oh, and I'm going to kind of go back. So one thing I have learned, if the NASA Space Centers are really unique in that they kind of are oriented for certain things, right? So every time I hear Cape Canaveral, I immediately just think of launch, or Kennedy Space Center, I should say. Every time I think of KSEC, it's like, okay, launch operations, right? Johnson Space Center is very known for their materials or infrastructure, and obviously ground control, right, mission control. I believe Langley does a lot of tests with like batteries and things like that as well, material science. White Sands testing facility exists, and they actually, as far as I understood, I heard Miss Vanessa Weish, the director of Johnson Space Center, and the way she talked about White Sands seems like they're very integrated together. So food for thought, if you're ever interested in working for NASA, there's that kind of symbiotic relationship. I always heard of Los Alamos, but I'm going to admit I actually learned about White Sands facility probably about 7 or 8 months ago. Cool. A successful test for the terminal tracking system. Yeah, so we use the terminal tracking system for Dinkinish and Salam. are the smallest main belt asteroids ever visited by a spacecraft. Yeah, here's the meters and all these things. Some of the see, they give me these things, and I'm like, who is Anne Frank? So more asteroids near Earth. Yeah, more similar in size to many near Earth asteroids. Yeah. Yes, yes, we have brought back things. Yes. Oh, okay, okay. I did not know that. Thank you for that information. Oh. Oh, okay. Oh, I see what you're saying. Yeah. Cool, cool. Donald Johanson during Lucy's approach. There that is. I think there was supposed to be maybe some movement, but it's the slides. Solar array anomaly shortly after launching the spacecraft sent signals indicating the left solar had not latched properly. So there's that error I was mentioning earlier. But very, very little risk to the stability or the power, right? Everything was working just fine. The encounter will serve as an early test for the crucial terminal tracking system. System will keep the asteroid. Yeah, we already heard these things. So cool, cool. I am gonna stop talking. I hope you guys enjoyed tonight. This was my first time giving this spiel, this talk. So thank you, Mickey and the team out here at Nerd Night for having me. I really enjoyed this, and above all, I really just enjoy being a science communicator. So thank you guys for letting me play that role for you today. Awesome, yeah.
All right. Thank you, Ruben. Great talk. Who has the first question? All right. Amy.
So you were a teacher in your past life, and I was wondering if you were trying to encapsulate maybe like 3 main lesson points for kids about the Lucy mission. What would you say to them, to the students you used to have?
Yeah, if I could say something to my students right now, oh my gosh, I'm immediately thinking of JD and Mira and all these students. I tell them that we're doing some awesome stuff, that we're going to explore somewhere that's never been explored before, the Trojan Asteroid Belt, that we're going to learn and seek out material that we potentially have never seen before, or understand these bio and organic materials, and that we are continuing to pave the way for the future. I think these things are special, and I think satellite missions and orbital missions are just as important as those astronaut or moon missions, right? All the things that we've been hearing of lately. Yeah, yeah.
Somebody here had a question. There you go.
So I think 2 of those asteroids had collisions, and that's why NASA wants to study them. How does NASA know that? Because there's a bunch of shit going on out there.
Great question. The geological features, for as much as we can see, I believe they understand the geological features, and any thermal imaging from other satellite, other telescopes or cameras that they're able to see probably tell them that information. Specifically, the geological features. I know in our time in the academy, something we use is JMARS, and when we study craters and understand different sites to visit, we use a swim map. And what that map really tells us and identifies for us are key areas where water or ice may be. So I'm assuming something similar. It's got a lot to do with geological features and understanding how those things form. Yeah, not the greatest reply, but I hope that helps.
Hey, I think you kind of answered my question a little bit, but in terms of the other asteroids, are there any particular features of like why they were chosen in comparison to like other
Yes,
ones?
you actually triggered me, and I am so upset I didn't say it. There are different types of asteroids. So there's C-type asteroids, which I think are more common near Earth or in our main asteroid belt. Forgive me, one is a P-type, and I believe there's an M-type, and those are a testament to the composition that the asteroids have. Yes, yeah. Cool. Well, I hope that answers.
So I guess a certain amount of the asteroid belt might be from a collision with the Earth that kind of blasted off part of its mantle during its formation. And so I'm curious if the Lucy mission is trying to learn more about Earth by studying asteroids,
Yes.
and if the asteroids that were chosen were because of that.
Yeah. Hal Levinson is just amazing, and everyone at NASA. He developed the NEACE system and another program called SWIFT. They really do a lot of those studies on the formation of the solar system, and those software to understand and how that story is told. So by studying these collisions from the asteroids and understanding how some of those things came to be, they will better understand the formation of our solar system. It's kind of like by studying, we've been able to study some of the inner things we have, right? These close asteroids and things in the main belt, but we've never traveled to the Trojan asteroids, and we've never had things that are potentially from the Kuiper belt. So by seeing a lot of those features and understanding that science, we hope that tells more of our story about Earth. Yeah.
Do we take advantage of the time where Lucy is closer to the Earth and pick up things that it's collected or communicate with it more?
Yes. Forgive me if I wasn't clear. We cannot physically pick up anything. There have been missions where we can, where there's like where we can get stuff, but this one is purely camera, purely thermal, and imagery. So I believe the closest thing to your question would be like the John L. Johansson asteroid. Just using that as an advantage to like, oh look, a rock. Oh look, we could test our tracking system. So yeah. Loving the questions. Also, don't feel bad if you challenge me. Seriously, I probably work better under pressure. Yeah.
Compositionally, like in terms of mineral content or elements, like what are these asteroids made of, and or is there a lot of variation from one asteroid to another?
Oh man, you asked the question I was scared about. uh, I don't know enough about the actual compositions. Yes, yeah, I'm gonna be honest about that. I think carbon, but that's that's as much as you're getting from me guys tonight.
Do you have a favorite asteroid?
Ooh, a favorite asteroid. The Patroclus and Minucius. I think it's nice that they kind of lean in on each other. I think that was my favorite notice of the asteroids. Yeah.
How densely packed are the asteroid belts?
Yeah, awesome question. So the Trojan asteroid belt, I don't want to say it's dense or compact necessarily, but the orbit is so strong in the Lagrange points, the way that they work, they kind of keep everything in, and they're able to keep those things in and move in that style of orbit behind Jupiter and ahead of Jupiter. That's kind of why we want to go to see why that works the way it does. Yeah.
Do some of those asteroids like migrate out of those Lagrange points? Like, do they come to the inner or outer?
Yes, we believe Patroclus and Minucius are the pair that moved from the Kuiper belt many years ago. So we think that's where that came from. Yeah.
Hey, so I'm curious. You said there's a time capsule on there. Is it like just like a snapshot of like life, like what it was when they launched it, or like a plaque?
Yeah.
it
Typically,
like
NASA loves to leave things on spacecraft like symbols or I mean like I learned this just recently. They'll like mark things. They'll sign themselves on there or things. I am under the impression that they left these things on the space capsule if I'm understanding that right, and remember from his lecture. So yeah.
They didn't leave like a mixtape of our music or anything.
Right. Speaking of, how many of you have heard the Beatles song "Lucy in the Sky"? "Lucy in the Sky," the Beatles song, amazing song, classic. I wanted to say this earlier. Forgive me. I'm glad I remembered though. Thank you for triggering it. So, Lucy in the Sky was from the Beatles, and that was an obvious that we named it after Fossil. We promise. But as time went on, we learned of that neat portrayal between the Beatles because there's a diamond in the sky, and it's actually on. I promise I'm gonna get there. I think it's the Elori. If you know, please correct me because I'm passionate about this. I believe it's the Elori that has an actual lab-grown diamond, 39 millimeters by 1 millimeter, that acts as it basically shows us infrared. It splits the light beam into infrared light and invisible light. So Lucy in the Sky with a bunch of diamonds. Yeah. Pretty cool stuff. Any more questions? I'd love to hear them. I'm actually really happy you guys are asking me questions because I do love this stuff.
All right. I think this is our last question. Oh.
It's a group question. Hi. How much of the navigation is like preset versus how much of it is like modified from Earth throughout like the course of the mission?
Ooh, love that question. I don't know off the top of my head. What I do understand about missions is that, I mean, I think they can. I think they do understand like how to use the thrusters and all those things from ground control and mission control. But there's not so much because they let the orbital mechanics really take it away, as far as I understand. And that's kind of a testament to just capsules, right? Different flight paths where they may manually take, or astronauts may manually take over to potentially do things differently. So I hope that helps. I'm understanding them might be similar. It is different, I'm sure, but potentially similar for satellite missions. Well, that was the last question, so thank you guys.
All right. Thank you so much.